In 1799, a British scientist cut into a dead animal with scissors, hunting for stitches. He was certain someone had sewn a duck's bill onto a mole to humiliate him. There were no stitches. The animal was real. And that bill he was cutting into, it wasn't a bill. It was an antenna that reads electricity. He died never knowing. The scientist was George Shaw, keeper of natural history at the British Museum, and he wasn't a fool. Fake taxidermy was a real industry then. People stitched monkey torsos onto fish tails and sold them as mermaid mummies. So, when a pelt arrived from New South Wales with a duck's bill on a furry brown body, webbed feet, and a beaver's tail, suspicion was the rational response. He snipped around the base of the bill. No seams, no glue, nothing but continuous skin. Even then, he couldn't accept it. He wrote that it was impossible not to entertain doubts about the animal's genuine nature. And European naturalists went on arguing about whether this thing was real for roughly 90 years, not about some detail, about whether it existed as described. Aboriginal Australians had been telling colonists plainly that it laid eggs. Britain refused to believe them until 1884, when a naturalist went to Australia specifically to settle it, found a female with an egg, and wired the answer home. Nearly a century of argument. The people who lived there had been right the whole time. Here's the thing that sets up this entire video. Shaw was looking at the outside, the bill, the fur, the feet. And the outside was strange enough to make a trained scientist reach for scissors. The outside is by far the most normal thing about this animal. Every single time science has looked closer, opened it up, followed it underwater, put it under a microscope, sequenced its genome, and shown a different wavelength of light at it, it has found something that shouldn't be there. Not once, every time, including 3 months ago. So let's zoom in properly. 5 levels, each one worse than the last. Start where Shaw started, the level anyone can see from the riverbank. The platypus lives in freshwater rivers and streams in eastern Australia and Tasmania. A big one runs about 40 to 60 centimeters from bill to tail and weighs somewhere between 1 and 3 kilograms. So we're talking about an animal roughly the size of a small house cat. That's the last ordinary sentence in this video, because the body is an argument. The bill is broad, flat, and duck-like, except it is not hard like a duck's beak at all. It's soft, rubbery, almost squishy, covered in flexible skin. The tail is wide and flat like a beaver's, and it works as a rudder, but its main job is storing fat. A platypus keeps its emergency food supply in its tail. The feet are webbed like an otter's, but the webbing on the front feet retracts when the animal comes ashore, folding back to expose claws for digging. Swimming paddles that convert into shovels. The fur is genuinely remarkable engineering. It's dense, denser than a polar bear's, trapping a layer of insulating air so effectively that a platypus can spend 12 hours a day in cold water and stay dry against the skin. Now, Europeans found this combination unbelievable. But here's the detail I find most telling, and it came up over and over when people talked about this animal. Aboriginal Australians had known the platypus for tens of thousands of years, and they also considered it an anomaly. In Dreamtime stories, the platypus is explained as the child of a duck and a water rat, a creature born from 2 different worlds that should not have mixed. In one version, a young duck named Theralku disobeys her parents, swims downriver, and is caught by a water rat. The eggs she lays hatch into the first platypuses. Think about what that means. This is a continent absolutely saturated with animals that seem designed to unsettle you. Australia is where evolution went to experiment. And the people who lived alongside all of it, who knew every one of those animals intimately, looked at the platypus and concluded that this specific one required a special explanation. When the locals who deal with venomous everything say, no, That one's odd. The animal is odd. So that's level 1. That's the surface, the part you can see from the riverbank. A soft rubber bill, convertible feet, a fat storage tail, fur denser than an Arctic mammal's, on a body that looks assembled from spare parts. Now let's open it up, because the internal design is where this stops being funny and starts being genuinely hard to believe. The platypus is a mammal. That's not in question. Fur, milk, warm blood, all of it. But it belongs to a group called monotremes, and there are only 5 species of monotreme left alive on this entire planet. The platypus and 4 kinds of echidna. That's the complete list. Everything else, every other mammal on Earth, went a different direction. The first way it breaks the rules is the famous one. It lays eggs. The female builds a burrow in the riverbank, sometimes 20 or 30 meters long, seals herself inside behind plugs of packed earth, and lays 1 to 3 small, soft, leathery eggs, closer to a reptile's egg than a bird's. She curls her body and tail around them and incubates them for about 10 days. Then they hatch, and the babies, which are called puggles and are about the size of a jelly bean, emerge blind, hairless, and entirely helpless. Those earth plugs are worth pausing on because they tell you how deliberate this is. She doesn't just dig a hole. She packs soil into the tunnel behind her at intervals, sealing the nursery off from the outside world, protection from flooding, from predators, and from the temperature swings above ground. She is, in a very real sense, bricking herself in with her eggs. And she stays. For weeks after hatching, the mother makes short trips out to feed and returns to a nest of blind, jelly bean-sized young that cannot regulate their own temperature, cannot see, and cannot move meaningfully on their own. Puggles remain dependent for months, typically around 3 to 4 before they first venture into the water. Then the mother feeds them milk, an egg-laying animal that nurses. This is the exact combination that broke European science, because in the taxonomy of the time, those 2 things could not coexist. Eggs went in one column, milk in the other. But here's the part that most people don't know, and it's much stranger than the eggs. The platypus has no nipples, none. So how does it nurse? The milk is secreted through pores in the skin of the abdomen. It seeps out onto the mother's fur, pools and grooves and folds on her belly, and the puggles lap it directly off her body. She essentially sweats milk, and her babies drink it out of her hair. There's a good evolutionary reason it works this way. Mammary glands are thought to have evolved from modified sweat glands, and the platypus preserved an early version of that system before nipples ever came along. So this isn't a defect. It's an ancient design that never needed updating. There's also a hidden benefit that scientists only figured out recently. Milk sitting exposed on fur in a warm, humid burrow should be a bacterial disaster. It isn't, because platypus milk contains an unusual antibacterial protein, one that researchers nicknamed the Shirley Temple protein for its distinctive curled molecular structure. It's now being studied as a potential weapon against antibiotic-resistant bacteria. The solution to the leaking milk problem is a protein that might help us fight superbugs. Keep going down. It gets stranger. The platypus has no stomach, not a small stomach, not an unusual stomach. It doesn't have one. In a typical mammal, food goes down the esophagus into a stomach, which is essentially an acid tank that breaks the meal down with hydrochloric acid and digestive enzymes. In the platypus, the esophagus connects almost directly to the intestine. There's no acid chamber, no pepsin. The genes for building those things exist in its genome as broken remnants. It had them once, and evolution switched them off and let them decay. Why would an animal throw away its stomach? The leading explanation is diet. The platypus eats insect larvae, worms, freshwater shrimp, small crustaceans, soft prey, mixed with a lot of hard shell and grit. A stomach's acid is expensive to produce and mostly useful for breaking down large, protein-rich meals. If your diet is a steady trickle of small, soft invertebrates, and it comes bundled with alkaline shell material that would neutralize your acid anyway, the whole system is a waste of energy. So it went. Which raises the next problem. Without a stomach, how does it break up food at all? With gravel. And this brings us to another absence. An adult platypus has no teeth. It's born with tiny teeth that fall out early in life and never come back. What it has instead are hard keratin grinding pads inside the bill. And when it's hunting on the riverbed, it deliberately scoops up small stones and grit along with its prey, stores everything in cheek pouches, comes up to the surface, and then grinds the whole mixture between those pads, using the gravel as a set of borrowed teeth. It doesn't have teeth, so it rinsed them from the river. One more absence before we move on. The platypus has no vocal cords. It can produce a low growl when disturbed, but it has no real vocal apparatus. It is, for practical purposes, a silent animal. So let's take stock of level 2. No nipples, no stomach, no teeth, no vocal cords. This is an animal missing an extraordinary number of the standard parts, and every one of those absences turned out to be a solution rather than a problem. And now we follow it into the water, where it gives up something even more important. A hunting platypus dives for around 30 to 40 seconds at a time, over and over, sometimes a couple of thousand dives in a single night, foraging along the bottom of a river. It needs to eat a huge amount to fuel that, up to about 20% of its body weight every day, and much more for a nursing female. Sit with that workload for a second because it reframes the animal. 2,000 dives is not a leisurely swim. That's a shift worker. 30 seconds down, a few seconds up to breathe, 30 seconds down again. Repeat it through the entire night, every night, for a lifetime. And it's doing that in cold water, which drains body heat relentlessly from a small animal. The platypus keeps a body temperature around 32 degrees Celsius, noticeably lower than most mammals, and that lower set point is part of how it affords this life. A cooler engine burns less fuel. The dense double-layered fur does the rest, trapping air so effectively that the skin underneath stays dry through hours of immersion. Everything about this animal's daily existence is a calculation about energy, and the moment it goes under, it makes the strangest calculation of all, one that sounds like a catastrophic design flaw. It closes its eyes, and its ears, and its nostrils, all of them sealed shut by folds of skin for the entire dive. This animal hunts in murky river water at night at the bottom while completely blind, completely deaf, and unable to smell anything at all. It voluntarily switches off every sense you and I would consider essential, and then goes looking for moving prey in the dark. If that were the whole story, the platypus would have starved into extinction 100 million years ago. It obviously didn't. So what is it using? Electricity. That soft, rubbery bill is not a mouth, it's an antenna. It's packed with tens of thousands of sensory receptors, roughly 40,000 electroreceptors arranged in stripes across the surface, plus around 60,000 mechanoreceptors that detect pressure and movement. And those electroreceptors do something almost no other mammal can do. They detect the faint electrical fields generated by the muscle contractions of other living things. Every time a shrimp flicks its tail, every time a worm contracts, the muscle activity generates a tiny electrical signal that propagates through the water. To us, that's invisible. To the platypus, it's a beacon. The system is more sophisticated than just detects electricity. Because the bill has both electroreceptors and pressure receptors, the animal can compare two different signals from the same event. An electrical pulse travels through water essentially instantly. The physical pressure wave from the same movement travels much slower. So by measuring the tiny delay between the electrical signal arriving and the mechanical one following, the platypus can calculate how far away the prey is, the same principle as counting the seconds between lightning and thunder, except performed automatically, underwater, in complete darkness, on the time scale of milliseconds. That's why you see a hunting platypus sweeping its head side to side as it swims. It's scanning. It's building a picture of a world it cannot see, out of electrical fields, and triangulating the position of animals hidden in mud. So the blindness isn't a weakness, it's a deliberate trade. Eyes are close to useless in dark, silty water, so the platypus shut down the senses that don't work down there and built an entirely different one that does. It didn't adapt its vision to the river. It replaced vision with something better suited to the river. To appreciate how rare that is, consider the company it keeps. Electroreception is not unheard of in the animal kingdom. Sharks and rays have it. Some fish have it, and it works beautifully in salt water, which conducts electricity easily. But fresh water is a far worse conductor. The signals are weaker, they fade faster, and detecting them takes a much more sensitive instrument. And among mammals, the entire class, thousands of species, this ability is essentially absent. The platypus and its echidna cousins are the exception. Everything else in our branch of the family tree lost this option or never had it. One small Australian animal is holding a sense that the rest of the mammal world simply does not possess. There's one more piece of hardware worth mentioning because it caused arguments of its own. Monotremes have an extra pair of bones in the pelvic region that no other living mammal has, historically called epipubic bones. And in the platypus's case, one element was given the wonderful name os paradoxum, the paradoxical bone, because nobody could work out what it was doing there. Even the skeleton of this animal has a part named after how confusing it is. And here's a detail that puts a fine point on how committed this animal is to its underwater strategy. Studies of its eyes have found features suggesting its ancestors relied on sight far more than it does. The platypus didn't fail to develop good vision. It had a visual system, and then evolution walked away from it because it found something that worked better in the dark. Level 3, then. An aquatic predator that deletes its own senses and hunts with a sixth one instead. Now we go smaller. Because at the microscopic level, the platypus stops being merely odd and becomes something close to a medical mystery. Look at the hind legs of a male. On the ankle of each one, there's a spur, a hollow, curved keratin spike about 15 millimeters long, connected by a duct to a venom gland in the thigh. The platypus is a venomous mammal. That alone puts it in a tiny club. Venom in mammals is extraordinarily rare. But it's how this venom works that makes it remarkable. It won't kill you. There is no recorded human death from a platypus. What it does instead is arguably worse. The pain is described by victims as immediate and overwhelming, and it does not stop. It can persist for days. In documented cases, it has lasted weeks, and some victims have reported hypersensitivity in the affected limb for months afterward. There is no anti-venom. And here is the detail that genuinely stops people. Morphine doesn't work on it. Conventional painkillers, including opioids, fail to control this pain because the venom doesn't act through the pathways those drugs block. It contains peptides that open ion channels in nerve cells directly, essentially forcing pain neurons to fire continuously, bypassing the entire system that morphine is designed to interrupt. In documented cases, doctors have had to resort to nerve blocks because standard analgesia simply did nothing. The most cited case involves a former Australian serviceman who was spurred on the hand while trying to help what he thought was an injured animal. He described the pain as worse than anything he had experienced, including shrapnel wounds. Morphine had no effect. The swelling spread up his entire arm within minutes, and the aftermath was the part that stayed with researchers. Months later, the limb was still hypersensitive, still not right. The venom hadn't just hurt him. It had rewired how his nervous system processed sensation in that arm. An animal the size of a house cat with no teeth that can produce a pain modern medicine cannot switch off. It's also seasonal. Males produce venom year-round in small amounts, but production ramps up enormously during breeding season, which points to what it's actually for. This isn't a hunting weapon. A platypus doesn't envenomate shrimp. It's not primarily defensive either. It's a weapon males use against each other, competing over females and territory. Males have been found locked together, spurs embedded in one another's bodies. Now here's the turn that makes this my favorite fact in the entire video. That venom contains a hormone called GLP-1, glucagon, like peptide 1. If that sounds familiar, it should. GLP-1 is the hormone behind an entire class of type 2 diabetes drugs. Humans produce it in the gut where it triggers insulin release and helps regulate blood sugar. The problem with human GLP-1 is that it degrades almost immediately. It is broken down in a couple of minutes, too fast to be useful as a treatment on its own. The platypus version does not degrade the same way. Because it evolved to function in venom, where it needs to remain stable and active, it is built differently, and it is far more resistant to breaking down. Researchers at the University of Adelaide and Flinders University found that monotremes evolved a form of this hormone that survives in the body far longer than ours does. So the same gland that produces a pain morphine can't touch is also producing a molecule that might lead to better diabetes treatment. And separately, because platypus venom activates pain pathways that opioids cannot block, researchers are mapping those exact mechanisms in the hope of developing painkillers for chronic pain patients who do not respond to existing drugs. Read that again. The animal that causes untreatable pain may end up teaching us how to treat untreatable pain. That's level 4. Now we go all the way down to the genome and to light itself. Every mammal you know, including you, has 2 sex chromosomes, X and Y. That's the system. 2. The platypus has 10. 5 X chromosomes and 5 Y chromosomes out of a total of 52, 5 times more sex chromosomes than any other mammal, and they don't behave like ours. During reproduction, they link together into a chain, and the entire chain is inherited as a unit. Nothing else in the mammal world works this way. When researchers examined those chromosomes closely, they found something that reframes the whole animal. One of the platypus X chromosomes shares similarities with the Z chromosome of birds. Its sex determination system has more in common with the chickens than with yours. The full genome, sequenced and then resequenced in far higher quality, tells the same story throughout. It contains genes associated with reptiles, genes associated with birds, and genes associated with mammals, all in one working animal. It has reptile-like genes for egg fertilization, sitting alongside the mammalian machinery for producing milk. It carries the broken remains of the stomach genes it abandoned. This is where I want to correct something, because it's the most common misunderstanding about this animal, and it matters. The platypus is not primitive. It is not a half-finished draft, an evolutionary rough sketch, or a missing link caught mid-transition. That framing has been around since Shaw's time, and it's wrong. This is a lineage that has been running for something on the order of 166 million years, and every one of these traits is a refined, functional adaptation to a specific way of life. The reason it looks like a mixture of reptile and bird and mammal is that it branched off from the rest of the mammal family tree extraordinarily early, before many of the features we think of as standard mammal equipment had been standardized at all. It isn't behind us. It went sideways, very early, and then it got extremely good at being exactly what it is. Which brings us to the last 2 things, and these are the ones science genuinely cannot explain. In 2020, researchers doing routine work on museum specimens shone ultraviolet light on platypus fur. It glowed, a soft blue-green fluorescence, absorbing UV and re-emitting it as visible light. They checked it against wild specimens and captive animals and confirmed it. Platypus fur is biofluorescent. This is an animal that has been studied obsessively for 220 years, and nobody had thought to point a blacklight at it. Nobody knows why. The leading guesses involve communication in low light, or camouflage against UV-sensitive predators, or possibly nothing at all, a side effect of fur chemistry with no function whatsoever. It remains an open question. Then, in March of 2026, months ago as of this video, the platypus did it again. A biologist named Jessica Dobson was examining platypus hair under high-resolution microscopy, looking at melanosomes. Melanosomes are the tiny structures inside cells that produce and package melanin, the pigment that colors skin, hair, and feathers. And for more than 50 years, biology had a clean rule about them. In birds, melanosomes can be hollow. In mammals, they are always solid. Hollow ones create nanostructures that bend and refract light, which is how a peacock's tail and a hummingbird's throat produce those brilliant iridescent colors. Dobson found that platypus melanosomes are hollow and spherical like a bird's. Her team checked their database against other mammals, marsupials, rodents, primates. Nothing. As far as anyone knows, the platypus is the only mammal on Earth with hollow melanosomes. A rule that had held for half a century broke on a single animal again. Here's the part that makes it a genuine mystery rather than just a curiosity. In birds, hollow melanosomes exist to produce dazzling iridescent color. The platypus is brown. Plain, dark brown. The melanosomes are scattered randomly through the hair rather than arranged in the ordered nanostructures that generate iridescence. So they aren't doing the job they do in birds. Then what are they doing? Nobody knows. One hypothesis is that they're a leftover from an aquatic ancestry, or that they play some role in insulation, or in how the fur handles light underwater. Another is that they connect somehow to the fluorescence. All of it is speculation. As of right now, the answer is unknown. 227 years after George Shaw took a pair of scissors to that pelt looking for the trick, we are still finding things in this animal that break our rules and that we cannot explain. And I want to close with one more, because it changes how you should picture this whole story. In 2013, paleontologists at the University of New South Wales were working through limestone from the Riverslea fossil site in Queensland, material that had, in the finest tradition of this animal, been sitting forgotten in a cupboard. In it, they found a single tooth, one molar. From that one tooth, they described a new species, Obdorodon theralcuschild, named, fittingly, after that Dreamtime story of the disobedient duck. It was a platypus. It was about a meter long, roughly twice the size of a modern one, about the size of a small child. And unlike the toothless animal in our rivers today, it had large, fully functional teeth. Wear patterns on that molar suggest it was crushing hard prey. The researchers concluded it would have been capable of killing and eating lungfish and even small turtles. There was a giant toothed platypus hunting turtles in Australian freshwater pools somewhere between 15 and 5 million years ago. That discovery did something bigger than adding a species. Scientists had assumed platypus evolution was a fairly tidy, linear affair, a straight line of ancestors leading neatly to the animal we have now. One of the study's authors said the discovery was a shock precisely because it revealed unexpected side branches on that tree, some of which became gigantic. They weren't a straight line. They were a radiation, a whole family of variations spread further than anyone assumed. We even have fossil evidence of platypus relatives from Patagonia in South America, dating back 61 million years, from when Australia, Antarctica, and South America were still joined. Monotremes once ranged across a supercontinent. Of that entire ancient radiation, 5 species remain, 4 echidnas and 1 platypus. the last survivors of a branch of mammal life that went its own way before the dinosaurs died and never came back to rejoin the rest of us. There's one more thing I've been saving, and it's my favorite, because it's the only fact on this list that makes the animal feel less like a puzzle and more like a person. The platypus sleeps around 14 hours a day. That part isn't shocking. It burns enormous energy hunting. What's shocking is how it sleeps. Researchers wired platypuses up and measured their sleep stages and found that a platypus spends more time in REM sleep than any adult mammal ever studied. Over 8 hours a day, close to 60% of its total sleep. For comparison, you spend about 25% of yours in REM. REM is the stage where, in humans, dreaming happens. During it, the platypus's bill twitches vigorously. Its head moves. Its closed eyes dart back and forth behind the lids, the rapid eye movement the stage is named for. It looks exactly like a dreaming dog does, except more so for longer than any mammal we've ever put electrodes on. Does it dream? We don't know. Researchers are careful to say that the behavior is there, but the experience is unknowable. But the picture is hard to shake. An animal curled into a ball at the end of a tunnel, tail wrapped over its face, bill twitching for 8 hours a night, the deepest dreamer in the mammal world, if it dreams at all. And if it does, it would be dreaming in a sense we don't have. Not pictures, electricity. Which brings me to the last fact, and it is the one that actually matters. This animal is in trouble. The platypus is currently listed as near threatened, and its numbers have been falling. The reasons are the ordinary, unglamorous ones. Rivers drying under drought, waterways dammed and diverted, riverbanks cleared so the burrows have nowhere to go, and illegal net and trap gear that drowns an animal which has to surface every 40 seconds to breathe. It vanished from South Australia's mainland rivers a long time ago. Its range is quietly contracting. There is a bitter irony in that, given everything we have just covered. We spent 90 years arguing about whether this animal was even real. We spent 2 centuries calling it primitive. We only found out it glows in 2020, and only found out about its impossible pigment structures in 2026. There is venom in its ankle that might teach us to treat pain we currently cannot treat, and a hormone in that same venom being studied for diabetes, and a protein in its milk being studied against antibiotic-resistant bacteria. We are still, right now, in the early stages of understanding what this thing is, and the window in which we can find out is not guaranteed to stay open. The bright spot is that it responds when we act. People in Melbourne have watched platypuses return to rivers that were restored. This is a solvable problem. It just requires that we bother. So, why does the platypus get weirder the closer you look? Because every level of magnification is a different answer to the same problem. From the riverbank, it is a jumble of borrowed parts. Open it up, and it is an animal that solved digestion by deleting its stomach and teeth. Follow it underwater, and it is a hunter that deleted its own senses and built a better one. Look at its cells, and it is a venom that defeats morphine and might cure diabetes. Read its genome, and it is 10 sex chromosomes and a sex determination system borrowed from birds. Shine the right light on it, and it glows for reasons nobody can name, through pigment structures that should not exist in a mammal. George Shaw was looking for stitches. He was asking the right question in the wrong way. The platypus really is assembled from parts that do not belong together, not because a taxidermist sewed them, but because this lineage split off so early and so completely that it kept working with a toolkit the rest of us abandoned, and then spent 166 million years perfecting a version of life that no other mammal ever attempted. It is not a joke, or an accident, or a mistake. It is the last messenger from a branch of the family that went a completely different direction, still out there tonight in some dark Australian river, swimming with its eyes sealed shut, hunting by electricity, glowing faintly in a light it will never see, and then going home to sleep in a tunnel and dreaming harder than any of us. Every time we look closer, it has something else it has not told us yet.